Hi everybody, this is the third video in a series on solving higher order polynomial equations by factoring. We're going to use a new technique in this video. Again, these are the rules that we've gone over. If you want to see a more in-depth treatment of these rules, check out video number 1. Links below. Okay, I'm trying to solve the equation x cubed plus 2x equals 6 plus 3x squared. Now, I'm going to solve that by grouping. And the reason I'm going to do that is because I see that it has an even number of terms, so 4 terms here, and each one is a different degree. I'm going to set it equal to 0, and I'm going to write it in standard form so that my exponents go in descending order. Now, factoring by grouping is something that you just get used to, and you'll start to notice patterns. Like you'll notice the pattern of 1, -3, 2, -6. I think there are some shared factors there. So pause the video for a second, see if you can factor this one by grouping. Here goes. There's a greatest common factor of x squared among the first 2 terms. And that gives me x minus 3 left over. So I'm looking for x minus 3 to be left over from the second set. In order to do that, I need plus 2. This combines to x squared plus 2 times x minus 3 equals 0. I'm remembering always to keep that equal sign there. Each one of these gives me solutions when I set them equal to 0. To get the real solutions, I set x minus 3 equals 0, and I get x equals 3. I know that I need 3 solutions, though, so there must be some imaginary solutions. So I set x squared plus 2 equal to 0. I'm going to solve this one by extracting square roots because it's so simple, and I don't really want to go through the trouble of the quadratic formula. So I get x squared equals -2, or x equals plus or minus the square root of -2. In simplified terms, that's plus or minus I root 2. So I've got 3 solutions. One is positive 3, and the other 2 are plus or minus I root 2. I want you to pause the video and try problem 5 on your own. Set equals 0, factor by grouping, get some solutions. Okay, the solutions you should get are -3, -1, and 1. 3 real solutions. Let's see how that happened. When I factor this one by grouping, I have to take a -1 out of the second set so that I have that x plus 3 going all the way across. So this factors to x squared minus 1 times x plus 3. Remember to keep that equal to 0. Now x squared minus 1 still factors. That's itself a difference of squares. So I've got x plus 1 times x minus 1 times x plus 3, and I can see 3 real solutions. -1, +1, and -3. All right, hope that helps.